Lifting a state up. Often, several components need to reflect the same changing data. We recommend lifting the shared state up to their closest common ancestor. Let's see how this works in action. We want to create a temperature calculator that calculates whether the water would boil at a given temperature. We will start with a component called boiling verdict. It accepts the Celsius temperature as a probe and print whether it's enough to boil water. Let's create a CodePen from React start point at this link and fork this CodePen. What we need to do is to create a functional component boiling verdict. Let's go ahead and create a function boiling verdict which accepts probes. In this function we check the temperature Celsius, check whether it's greater than 100 degrees or not. If it's yes, return the water would boil. And the else part, return the water would not boil. Let's use the boiling verdict component in the app component. Let's rename it the name of app to boiling verdict and put the h1 inside a div because we need to add another element beside h1, and that is boiling verdict component we already created, and set the Celsius to, let's say, 90 and check the result. As you see, the message the water would not boil will be shown here, and if we change it to 120, the message replaced with the water would boil. So what we did here is to create a boiling verdict which checks the Celsius and say the correct message. Next, we will create a component called calculator. It returns an input that lets you enter the temperature and keep its value in this.state.temperature. Additionally, it renders the boiling verdict for the current input value. Let's create the calculator component. Here, class calculator, which extends React.component Here we need the constructor method because we need to set the state here. Constructor accept probes, and here first of all we need to call super probes, and this dot state here is the initial value for state, which is temperature. Set it to 0. Let's create a render function. It returns and input and uses the boiling verdict. So first of all, create an input, type text, and the value would be this dot state dot Celsius. Also, we need the onChange method to handle the change in this input box, which it would be onChange. We need to create it in the class, and a line break, and here where the boiling verdicts goes, here. The point in boiling verdict is that we want to pass the temperature to boiling verdict, and that's gonna be the state.temperature. This state.temperature will be passed to the boiling verdict as a probes. Celsius would be this state.temperature. Let's format the code and replace the boiling verdict in app component with the calculator. Oops, there is a mistake here. We need to return this JSX. We need to implement the onChange method inside the calculator component. Let's implement it. onChange equals arrow function, and here we need the event method, event object, and use this set state and set the temperature to the given value by user, which is event.target.value. Put a semicolon and check the result here. Let's change the value to 100, and you see the water would boil, and if we change it to 10, the water would not boil. There is another requirement. In addition to a Celsius input, provide a Fahrenheit input. They are kept in sync. We can start by extracting a temperature component from calculator. We will add a new scale probe to it that can either be C or F. I wanna save this version of our code. Here I click save and fork it again and rename the boiler verdict to V2. Great. It's time to create class temperature input, which extends React component constructor probes. Let's create a constant for scale name, which is an object with two properties. The first one is F, which stands for Fahrenheit, and C, which stands for Celsius. Inside the temperature input, we wanna set the super probes and set the default temperature for state, the state, temperature 0. In the render method, we want to render a field set and there is a legend which is temperature, in, and here we need to find the scale name of this dot probes dot scale. Close the legend, and there is input. I just copy the input from the sample here and copy it right here and close the field set. So what we need to do is to copy the onChange method also from calculator and put it inside the temperature input like this, and here we need to use the temperature component we created. There is a property which is scale. We set the scale to Celsius. Also, there is another scale which is Fahrenheit. Great. You see temperature in Celsius and temperature in Fahrenheit. Let's change the value, and you see it doesn't work, but it accepts the value, but the boiling verdict does not work, and also the temperature in Fahrenheit does not sync with the temperature in Celsius. Let's resolve this problem. Here we can now change the calculator to render two separate components. We have two inputs now, but when you enter the temperature in one of them, the other doesn't update. This contradicts our requirement. We want to keep them in sync. We also can display the boiling verdict from calculator. The calculator doesn't know the current temperature because it's hidden inside the temperature input. You see these problems here. When you set the value inside the Celsius, there is no change inside the temperature in Fahrenheit, and also the degree inside temperature doesn't apply to this message because it's need to show the water would boil at this degree. Before jumping to lifting the state up, let's write the conversion function. First, we will write two functions to convert from Celsius to Fahrenheit and back. So let's create these two functions. Here, this is two function to Celsius. It gets the Fahrenheit and convert it to Celsius, and also there's another function which is to Fahrenheit, which get a Celsius temperature and convert it to Fahrenheit. We will write another function that takes a string temperature and a converter function as an argument and returns a string. We will use it to calculate the value of one input based on the other inputs. It returns an empty string on an invalid temperature, and it keeps the output rounded to the third decimal place. Let's add this function at the end of that two functions. I mean, in this sample, the temperature inside this input box is completely different from the temperature inside this one, and both of them save the temperature degree inside their own local states. However, we want these two inputs to be in sync with each other. When we update the Celsius input to Fahrenheit input should reflect the converted temperature and vice versa. In React, sharing the state is accomplished by moving it up to the closest common ancestor of the component that needs it. This is called lifting a state up. We will remove the local state from the temperature input and move it into the calculator instead. If the calculator owns the shared state, it becomes the source of truth for the current temperature in both inputs. It can instruct them both to have the value that are consistent with each other. Since the probes of both temperature components are coming from the same parent calculator component, the two inputs will always be in sync. First, we will replace this.state.temperature with this.probes.temperature in the temperature input component. For now, let's pretend this.probes.temperature already exists, although we will need to pass it from the calculator in the future. So first of all, what we need to do is to change the temperature input component. This.state.temperature will be changed to this.probes.temperature. This is the first change to lifting the state up. We know that probes are read-only. When the temperature was in the local state, the temperature input could just call this.setState to change it. However, now that the temperature is coming from the parent as a probes, the temperature input has no control over it. In React, this is usually solved by making a component controlled. Just like the dump input accepts both a value and the unchanged probes, so can the custom temperature accept both temperature and untemperature change probes from its parent calculator. Now, when the temperature control wants to update its temperature, it calls this.probes.unchange on temperature change. Okay, let's handle the change here. And inside the onChange, let's get rid of this code because we do not have any local state in temperature input, and replace it with this.probes.on temperature change event. And let's just set the value of target.value. The on-temperature change probe will be provided together with the temperature probe by the parent calculator component. It will handle the change by modifying its own local state, thus re-rendering both inputs with the new values. We will look at the new calculator implementation very soon. Before diving into the change in the calculator, let's recap our change to the temperature input component. We have removed the local state from it, and instead of reading this.state.temperature, we now read this.probes.temperature instead of calling this.setState. When we want to make a change, we now call this.probes.onTemperatureChange, which will be provided by the calculator. Now let's turn to the calculator component. We will store the current input temperature and scale in its local state. This is the state will lift it up from the input, and it will serve as a source of truth for both of them. It's minimal representation of all the data we need to know in order to render both inputs. For example, if we enter 37 into the Celsius input, the state of the calculator component will be temperature 37 and scale is C. If we later edit the Fahrenheit field to be 212, the state of the calculator would be this one. We could have stored the value of both inputs, but it turns out to become unnecessary. It's enough to store the value of the most recently changed input and the scale that it represents. We can then infer the value of the other input based on the current temperature and scale alone. The inputs stay in sync because its values are computed from the same state. Okay, let's change the calculator component. We need to set the on-temperature change inside the temperature input scale Celsius and set it to on Celsius change, and for Fahrenheit we need to set the on Fahrenheit change to this dot on Fahrenheit change. Also we need to set the temperature to Celsius. We will create this variable inside render, and for Fahrenheit like this. So let's create the handle method for changing data. The first one is on Celsius change, which accept the value, and it just uses set state. The temperature would be value, and the scale will be Celsius. Let's duplicate this code and convert it to Fahrenheit. and the scale is F. Let's format the code. In the render method, we need to use the conversion function. First of all, we read the temperature from this dot state dot temperature, and here in the constructor we set it to 0, and we calculate the Celsius by using try convert. First parameter is temperature and the second parameter is scale. Let's create the scale here and set the default scale to Celsius. The try convert accept the temperature and the conversion function, and the conversion function is based on the scale. So if scale is Celsius, we do not need to change its value, and the Celsius would be the temperature itself, M. But if it's not the Celsius, we need to use try convert and convert the temperature to Celsius. For Fahrenheit, if scale is Fahrenheit, there is no need to convert, and the temperature already is in Fahrenheit. But if it's not, we need to use try convert the temperature and use to Fahrenheit. Let's format the code. Oops, let's cut the code from the render method of temperature input and move it to render method of calculator input. Great. And here we need to cut the state from temperature input to calculator input. Great. As you see, we implemented the requirement here. If you change it to 100 degrees Celsius, the water would boil and it's converted to 12 temperature in Fahrenheit. Let's recap all the things we did in this sample. React calls the function specified as unchanged on the DOM input. In our case, this is the handle change method in the temperature input component. The handle change method in the temperature input components call this.probes.onTemperature change with the new desired value. Its probes, including onTemperature change, were provided by its parent component, the calculator. When it previously rendered, the calculator has specified that onTemperature change of the Celsius temperature input is the calculator's handle Celsius change method, And on temperature change of the Fahrenheit, temperature input is the calculators of handle Fahrenheit change method. So either of these two calculator method gets called depending on which input we edited. Inside this method, the calculator input asks React to re-render itself by calling this.setState with the new input value and the current scale of the input we just edited. React calls the calculator components render method to learn what the UI should look like. The value of both inputs are recomputed based on the current temperature and the active scale. The temperature conversion is performed here. React calls the render method of the individual temperature input component with their new probes specified by the calculator. It learns what their UI should look like. React calls the render method of the boiling vertic component, passing the temperature in Celsius as its probes. React DOM updates the DOM with the boiling vertic and to match the desired input value. The input was just edited, received its current value, and the other input is updated to temperature after conversion. Let's go back to the code, and here inside the calculator component we need to change the boiling vertic Celsius to Celsius, not the state.temperature change, because if we change it, for example, to 100, it shows the water would boil, but it's in Celsius is 37. But if we change this to Celsius, it would work. If we change it to 200, you see the water would not boil because it's not enough to boil in Celsius. And if we change it to 12, you see it shows the water would boil. That's all about lifting a state up. I know it's a bit complicated because you need to know how the state works, how to lift the state off from the small components to the shared parent components, and that's a bunch of boilerplate. But let's try these samples more and more because it's very important, and you need to know how to deal with component and states shared between components in React.